Hi, we'll talk today about rationalizing the denominator, the standard form. Rationalizing the denominator means no roots in the denominator. Let's see some cases. So the first case is 1 over the root of a. And that would equal to 1 over the root of a multiplied by 1. We did nothing, we just multiplied by 1. And then we can just change that 1 into the root of a over the root of a. So we did nothing now. We just changed this one into this form. Anything we divide it by itself, we will get 1. Okay, let's see what will happen. So now we will have 1 multiplied by root of a over root of a multiplied by root of a. And that would equal to, we have 1 multiplied by root of a, it's root of a, over root of a multiplied by root of a, we can write it as root of a squared. And that would equal to the square root of a over a. And you can notice here that we have removed the root. Let's see the next case. So case number 2 says if we have 1 over the root n am, that would equal to. So now we want to remove the root. So what should we do? So the first thing, we'll just multiply by 1. So we have 1 over the nth root of a to the power m. We will just multiply by 1. And then we'll just change the 1 into another form. So a to the power m. And here we will multiply by the nth root for a n minus m over the nth root of a n minus m. Okay, let's see what will happen here. So we will have 1 multiplied by the nth root for a n minus m. And here we will have the nth root for a to the power m multiplied by the nth root of a n minus m. Let's see. So here we'll have nothing but the root because it's multiplied by 1. So we'll have a to the power n minus m. And in the denominator we will have the nth root for am multiplied by a n minus m. Basically, we can simplify this denominator here. So we can just rewrite it as the root of n for a to the power n minus m over the root of n for a m plus n minus 1 m. Just notice here that I've just summed these powers here because we have multiplication, so we'll sum the powers. So now what we will have, let me just make more space for me. So the final answer would be the nth root of a n minus m over the nth root of a. Here we will have n. So we can just simplify this expression more. So we will have the nth root of a n minus m over a, because this n and the root will just be removed. So we'll get this as a final result. Let's see an example. Example 1 part A says we have 2 over the square root of 3. So we want to rationalizing it. Let's see. So the first step, we'll take 2 over the root of 3 and multiply it by 1. Then we'll have 2 over root of 3. We'll just convert this one into the root of 3 over the root of 3, because we want to remove this root of 3. So after that, what will we have? So we have 2 multiplied by root of 3 over root of 3 multiplied by root of 3. That would equal to 2 root of 3 over root 3 squared. And that would equal to 2 root of 3 over, you can notice here that this square root and this 2 will just be cancelled, so we'll get 3 as denominator. So this is the last answer. Let's see part B. So in part B we have 1 over the third root of 5. So let me just write it again here. So we have 1 over the third root of 5. We will just multiply it by 1, and that would equal to 1 over the root of 3 of 5. And this one, we will change it into the third root of 5 over to the power 2. And here we have the third root of 5 to the power 2. Why I have done that, you'll see now. So we will have here 1 multiplied by the third root of 5 to the power 2 over, here we will have the third root of 5 multiplied by the third root of 5 to the power 2. Let's see. So 1 multiplied by this, so we'll get the third root of 5 to the power 2 over this expression here is nothing but root of 3, 5 multiplied by root of 3 for 5 to the power 2. That would equal to the third root by 5 to the power 3, and that would equal to 5, so we will get 5 here. And this is the last solution. Let's see part C. So here we'll just write this root as this, so we'll have 1 root of 7 over root of 7, and here's a to the power 2. And this we can simplify it as 1 over the 7th root of a to the power 2. Now we want to remove this root, so we will have 1 over the 7th root of a to the power 2 multiplied by 1, and that would equal to 1 over the 7th root of a to the power 2 multiplied by, we'll have the 7th root of a to the power 5 over the 7th root of a to the power 5. Why I have chosen 5 here? Because if you subtract 7 by 2, you'll get 5. So it's 7 minus 2, that would equal to 5. This is why I have used 5 here. Let's see now what we will get. So we will have 1 multiplied by the 7th root of a to the power 5 over, here it's nothing but a. So we will have a here, and the final answer would be the 7th root of a to the power 5 over a. Let me explain here why I get a, because when we have the 7th root of a squared multiplied by the 7th root of a to the power 5, we'll get the 7th root of a to the power 7, and that would equal to a, because this root and the 7 here will cancel.